Here we will learn more about the Python Iterators. They enable sequential traversal of collections, providing a powerful and memory-efficient way to process data in Python. Let's examine what makes iterators so valuable. They allow for sequential data processing, moving through elements one at a time. They provide memory-efficient traversal, loading only when what's needed. They support lazy evaluation, calculating values only when required, and they work seamlessly with both built-in and custom collections. To understand iterators properly, we need to distinguish between iterators and iterables. An iterable is an object that can return an iterator. Most collections in Python are iterables. An iterator is an actual object that performs the iteration, keeping track of current position. The iterables implement iter method, which returns an iterator. Iterators implement both iter method and next method. The next method returns the next value in the sequence. Here we have a string gfg. We convert the string to an iterator using the built-in iter function. Now we can use the next function to retrieve the elements one by one. The first call of next of it gives us the character g. The second call gives the second f, and the third call gives us the final g. This demonstrates how iterators maintain the position as we move through the sequence. Now let's create our own custom iterator to generate even numbers. We define a class called even numbers that will act as our iterator. First, we implement the iter method, which initializes our starting value to 2. This method returns self because our class is both iterable and an iterator. Next, we implement the next method, which defines how to get the next value. We store the current value in variable x, and then we update our state by incrementing n by 2 to prepare for the next even number. Finally, we return the current even number. To use our iterator, we first create an instance of even numbers, then we iterate object using iter, then we call the next of it. We get our first even number 2, and the second call gives us 4, the next even number. This iterator could continue indefinitely, producing all even numbers. Now we will handle the stop iteration. We start a list with 3 elements and convert it into an iterator. Then we set up a while loop to fetch the values. Inside the loop, we use a try except block. We attempt to get the next value using the next method. If successful, we print the value. When the iterator is exhausted, it raises a stop iteration exception. We catch this exception and print a message and break the loop. This pattern allows to safely exhaust an iterator without any errors. Let's recap the theory behind the iterators. They are Python's primary mechanism for traversing data structures. The key distinction: iterables contain data while iterators handle the traversal logic. An iterable is any object that can return an iterator when the iter function is called on it. An iterator is an object that implements both iter method and next method. The most common iterables in Python include list, tuples, dictionaries, and set. Each of these collection types has built-in support for iteration, making them convenient to use in for loops and comprehensions.